I think that we can get started. Other people can join, they're welcome to, but we'll move this party along.
Okay. Cool. So the title of this talk is, it's mostly about IPython today. I don't know, like, I hope there was like a way to have a survey here, or something like a poll. It's like how many people use IPython. I'm not really sure what the level of the audience is, but I think the people that will mainly derive a good amount of information from this is the people who have just like played with it a little bit or don't know much about it. So it's kind of like a mostly an entry-level talk about IPython. If you have been mostly using the Python REPL and have not really used much of the IPython REPL. So I hope that's okay. Yeah, and in between, if you guys have any questions, definitely let me know. Kind of would be nice to make it an interactive session too. Or we could do questions at the end. I have like in between slides that remind me to check if there's any questions from the audience. So I think that helps. Oh yeah, there you go. It's a poll. Let's say yes. Cool. So this talk, I'm just to inform you, this talk will mostly be split into two halves of the screen, where one half I'll show you slides and the other half is going to be me working at a terminal. So unfortunately, it's not going to be fancy slides and all that stuff. You're going to be staring at a black terminal for a good part of the presentation. Just fair warning, because I believe like the best way to demonstrate the features of IPython is just like, demonstrating that to you right in the terminal.
Bit ominous.
I wholeheartedly agree.
So just a little quick thing about me. I've been a software developer for about 20 years. Started developing software using like desktop applications and stuff, believe it or not. I don't know if people have heard of Power Builder. That's how I started my work a long time ago.
I did a lot in Power Builder when I started too.
Power Builder, yeah. That's like the kind of software where you come in and like you don't really need to have a computer science degree. You can just like have some. You kind of learn just by looking at. You didn't really need much of computer science knowledge to do your stuff in there, I would think. So, but it was pretty good. Got the job done. So over the years, I did web development, and I think I went through like Java, .NET, and all that. But around 2009 or 10, I came across Python, and ever since I started doing Python, I kind of really wanted to make it my full-time job. I tried to get something that I would work mostly with Python, and that's pretty much happened since 2011. So I've been working with Python for almost about close to 10 years now. In between, there were like jobs that I switched away from Python, but for the bulk of the 10 years, I've been mostly doing Python, being familiar with this ecosystem, tools and all that stuff. So mostly Python, SQL, data engineering, backend web development with Django, Flask, stuff like that. And I'm currently working, this was actually asked by my company to add on the site. I'm currently working for a company called Alidate, which is a remote first company. They are based out of Bethesda, and we're like aggressively hiring. So in case anybody wants details, do not hesitate to reach out to me later. Okay, so what's the agenda for today? The agenda is mainly, I'll be demonstrating to you what features IPython has, the different kinds of features. Now, IPython has like a lot of features, but I'm going to concentrate mostly on the, basic Python developer, that how it helps in general software engineering, a subset of it that uses mostly, that's advantageous mostly for software engineering. And then after that, we will actually go and into a little bit of detail on how the internal machinery of IPython is. It's not really necessary for you to know this to use the tool, but I just felt like it was a very interesting series of developments, how they built the internals of it, and then how it has metamorphosized over the years into something much, much bigger than what it started from. And then the third thing is I will try to see if we can demonstrate a big part of it, which is integration of the IPython kernel into other programs. So for example, if you use the Python REPL, and if you used PDB, you can actually integrate PDB with the IPython kernel, which will give you the same PDB commands, but in an IPython shell, which is definitely more advantageous than vanilla PDB, which you will also see here. And then other frameworks like Django Flask provide their own shell. And if you have IPython, then these web frameworks have the capability to actually use the IPython shell itself, which again makes it really easy for you to use the Django or Flask shells. So we'll see if we can demo that. I'm not sure if I'll get to that, but we can see that. So what's just a little note about the origins of IPython. It was actually the main thing is it came from a exploratory scientific environment. It did not come from like a like software engineering enterprise business kind of a source. It was developed by Fernando Perez when he was working as a graduate student. He was really used to like during his exploratory findings, he was used to Mathematica, but he really didn't like the fact that it was not free, first of all, pretty expensive, I think. But it also had a bunch of features that he thought would be nice to port over to the Python REPL. So he kind of wanted something that was in Python that was like Mathematica, but still wanted the advantage of working with Python. So that kind of encouraged him to try to see if he can make a better Python REPL. Okay. So what are the goals of IPython? If you look at the IPython site, the IPython goals are numerous. They have like a lot of things that they want to achieve. But I kind of picked out two that like are most important from a software developer's perspective, which is it will give you a shell, a Python shell, which is supposed to be a Python shell with bells and whistles, like a lot more functionality that will make you more productive with the Python REPL. And the second thing, which is more fascinating, is the fact that with the IPython interpreter, you can actually embed that into programs. You can write a Python program, and in between, you can say import IPython, roughly to the tune of import IPython interpreter start, or something like that, where if you run your Python program, it's going to run your whole Python program, and suddenly it'll stop and then bring up an interpreter, and it'll preserve the context of the program. This was really valuable in terms of like when you're doing, again, exploratory work in research. Say you're running like a machine learning model or something like that, and after a long time, it generates a model, it trains a set, and then you just want to see now, in the context of the program, what are all the variables that the model has. So you can introspect the program right at that point. So that it serves as a way to do that too. So I'm gonna see if we can give you a quick taste of how it is to work in IPython here. So is the terminal big enough for you guys to see? Or should I increase the font a little more?
It works for me. For everybody else.
Yeah,
Yeah, I can see
terminal's
it.
fine.
Okay, good, cool. So so I just did a pip install IPython, and then I was able to install it and brought up IPython on my terminal. So I'm going to just copy and paste this program here, and we get a good idea of how it. So right away you can see that you can copy and paste if you copy it from some other place like GitHub or some other place which has like sufficiently well indented code or correctly indented code in Python, it'll work in IPython. You can directly paste it over here. So you copy it, paste it, and now you can say, so if you hit tab, you can get autocomplete here. So autocomplete. So let's say I bring up something here. So this is like a pretty simple program. It just it gets an URL and then it uses URL lib to get the HTML of the page and then returns the page HTML. And just for caching purposes, you have argument where you can say, hey, if it's not in the dictionary, go and fetch it. Otherwise, just return what's in the dictionary. So let's execute this here. So now when you execute this, what you see is an exception. And then you can see that the exception is a little more like nicely formatted. You got the arrows and stuff, and then of course the color and the it just makes it looks a little nicer. So here you see that it says, oh, URL lib is not defined. Okay, so let's say I have to import. You can see the syntax highlighting there, and then you can say URL lib. Okay, so now if you run it again, okay. So now you get another exception which says module URL lib has no attribute URL open. It's probably because this was I don't know if it's like Python 2 or something, and I'm using IPython and Python 3. So now I want to see like, okay, it has no attribute called URL open. So how do I know what's in URL lib? So URL lib, I'll try to see if I can use the autocomplete. URL lib. So I don't see any URL open or anything anywhere. So you could either go and look at one of these and then tab and then see whether it's there, or there is another way where you can in IPython you can actually look and dynamically introspect objects to see using wildcard matching to see if you can get the function that you need. So you can say something like, oh, let's say so if you say, hey, there's something in between, but then I want a URL open here, it'll tell you that you can get it within with this wildcard match. You could probably do stuff like this too. Okay, I guess you probably need. No, I guess you can't do that. Can you? Oh, okay. So you can actually put wildcards anywhere in between, and then you'll be able to see. It'll be able to give you what's available, what that satisfies that wildcard.
Can you just do a
So,
star out front? Can you just do star.url star?
right, star.url star. I think it won't like be able to guess how many levels deep it'll go. Like you would have to know, at what stage it is at. But you could say something like, hey, what is the method that starts with an A? Something like, so if there's nothing like that, then it won't give you. It's like, but you can say, sorry, I think I missed a star there. Yeah. So you can have wildcards in between, but like for example, if I say, yeah, I guess that'll work, but it just gives you the next level, right? It doesn't go like beyond that. Yeah.
Cool. Still super cool.
Yeah, this is a pretty nice functionality here. Another thing you can do is you can say, hey, so urllib dot request dot URL open was your method. So what is it actually about? So if you put a question mark after it, it actually gives you the doc string of that method. So you actually know what it actually does. If you can get an idea. This method has like a very, very detailed doc string. So you can see like the pages that you can read if you want to know what it does. But this is basically like, looking, I think it's the same as doing the help object in a regular Python REPL. Another thing that you can do is that if you put a double question mark at the end, it'll actually give you the whole source of the method if it can fetch the Python source. Some methods are in C, of course. You can't fetch those source code, but if it's in Python, it'll be able to show you the source. So now let's do this. So let's go back to what we were doing before. So I go back. So up arrow, you can go back to where it was before, and then you can just say request.url open.url, and then do web lookup. Now let's see. You can also do Unix style, the control R searching in the command. So it's control R, and then web. And then you can go to the call. Go back to this. Let's say http://bin.org. So now it's able to fetch you the data, the very obfuscated looking HTML here. So I think that's like a taste of what it is to work with IPython. I will go next and then see we can. Yeah. So just want to lay it out here what the features are that you can expect when you're working with IPython, which is you get syntax highlighting, and then you get tab completion. We saw that. And then you have dynamic object introspection, wildcards, all that stuff, and the fact that you can do question marks or double question mark to get information about the object. It also has searchable command history, very similar to the Unix shell that you can just type a command and then it'll give you a history and you can search back and forth about it. Another good thing here is that it gives you access to the underlying shell. So let's see if we can go back here. All right. So once you're in IPython, you can even type in Unix commands like ls-al, stuff like that. You don't have to go out of the shell to type these Unix commands here. And then we also can, so you can do just ls-l, but mostly the way you type Unix commands in IPython is preceded with a exclamation mark, which is the shebang or bang. That's some commands you can do just the Unix command itself, but others you can say, hey, I can type the Unix command with the bang, which is pretty much easy. So like, for example, I would say cat. So you can type anything here you want. So cat, or you can even do like, you can bring up women here, and you can go back on. And another thing you can do is you can actually save the output from a Unix command onto a variable. So you can say my list equals ls-al. So now my list will actually have a list of all the, so it'll take ls-al, and every line that it sees from there will be put into a list. So if you say, yeah, so like 110 lines, stuff like that. So you can do a lot of good things with it here, since you don't have to leave the IPython shell. You can also edit, run, and debug scripts. Let's see. So another thing that you can do is you can run Python scripts right within the shell itself. You don't have to exit it and say Python run a command. So for example, I have this, let's say, I showed you this a little bit ago. So I have this program which actually takes a random sample and then generates a random sample list, and then calculates the mean, median, and mode out of that. So you can actually run the program right from here. You can say %run. So percentage is what's called a magic command. There's a bunch of magic commands in IPython. The most popular ones are the one which is %run. There's also a %timeit, %debug, stuff that helps you in your regular workflow. But let's see how you can run a Python script within the IPython shell. So if I say run calcs.py, it'll just run and give you the mean, median, and mode out of the random sample list. Now, another thing which is advantageous to when you for running the program here is you can actually, like I said, introspect the variables that you have exported as module level. You can, because what it does is once it runs the program, it preserves the exported variables that's available at the module level. So for example, let me type this here and see. So let's say I have a global variable. I put this argument into a global variable. And then I'll leave the values here. But for example, so let's say I want to run this here now. So now let me run it again. And then, all right, I get this. But say I want to see the sample list that I ran this program on. I can just see the list from the variable that has been exported. You see it right there. This is the advantage of running a program within the IPython shell itself. So that's running. Another thing you can do is you can time programs. So like, for example, if I say percentage run, if you have the -t switch, it'll time the program. So, okay, that's not very helpful. So let's see here. Let me try to, so 10 million, 10 million. Let's run this now. Takes a while. There you go. So it gives you the same thing as the Unix time command, I guess, but you can do it when you're running a Python program right here. That's timing. You can also debug scripts. So you can say run -d. Let's stop py. And it will actually start running the program, and it'll give you a prompt, just a PDB prompt at the first line. And then you can do the same things that you do over at when you run PDB. So I noticed that I installed a program called IPDB. It's just a PDB with IPython on top of it. So you have to install that separately. I'm not sure you have to install it separately for this to work, because I think you can do it directly via the IPython shell. But if you're doing running a Python separately, Python program, you will need IPDB for that. So yeah, so that's how you debug a program here. Taking a while. Okay. All right. So that's what I have about IPython here, I think. Yeah. So any questions from anyone so far about all this?
No, this is great.
Yeah, it's something that I like. Whenever I have download a repo and then do pip install -r requirements.txt. The next thing I do is pip install IPython. So
Nice.
Yeah. So if there are no questions, I'll go to the next part, which is how does what is the internal machinery of IPython? Like, how did it initially start, and where is it now? So initially, when IPython was started, it did a bunch of things, and it was all in like one, I would say effectively one binary, that where the programs could not be separated based on their functionality. So what happened was it had a console, and it had the IPython kernel, which is actually the core where the commands from the console are sent to the IPython kernel. It provides all kinds of functionality like tab completion, all the stuff that, syntax highlighting, everything. And then it sends the command, it sends the results back to the console. So after a while, they also added something called a Qt console. So you can actually, when you type IPython --Qt console, if you have Qt installed, then it'll open a separate window, into which you can type your Python commands. Plus, it has the added functionality and the GUI advantages of Qt, like you can have graphs and all that stuff, I suppose. And then what actually happened after that was a very, again, was somewhat of a game changer when they introduced a notebook server, where you could start up a web server and then have a browser. And then in the browser, you could type in the commands and you can actually, the browser actually effectively works as a IPython REPL. And the advantage being you can, copy and paste and, preserve history all right in front of you, which is, I think, notebooks are pretty much, very much widely used nowadays in research, as well as in like, many enterprise businesses, I think. So all these were like all bundled together previously, and it was like one project. So what they did was they felt like it would serve them better, the community better, if they separated the functions for each, so that they are available separately for other programs to use. The reason they did that was, so basically how they separated it was they separated the kernel from the components where it sent and received messages from. So anything that you type into the console or notebook or the Qt console, which is the user-facing interface, is communicated. The data is communicated to the IPython kernel via what's called a 0MQ, the queue, with JSON messages. So the format was like standardized onto this, so that the reason, of course, for this was that if you wanted to create further new UIs, they could use the same set of communication channels to communicate with the IPython kernel. Okay, let's go back to that. So in terms of separation, they wanted to separate the user interface from the actual functionality in IPython. Another reason for separating was the fact that then the thought came about that why just for Python? Why can't it be reused for different other languages? So like, why can't we have a notebook environment for Clojure or some other language that people were using for research, something like that? So this actually helped. The separation of these two UIs from the kernel helped people to write other language kernels, which they could use to communicate to and fro from the notebook servers as well as the Qt consoles. When it comes to language kernels, so just as it's depicted here in the diagram, now language 1 can also communicate with the notebook server, and the Qt console. Language 2 can also communicate with that, besides IPython. There's a difference though. There are two types of languages that you can, kernels that you can write if you want to go plug into the IPython ecosystem. One is called a wrapper kernel, and the other one's called a native kernel. So the wrapper kernel is used for languages that do not have the internal machinery for themselves to communicate using 0MQ and JSON to the user interfaces. They kind of piggyback on what the IPython kernel actually does and says, hey, I'm not sophisticated enough to do this. Here are my messages. You take care of sending them and getting them back for me. So something like a language like Bash, if you needed an IPython terminal for it or a notebook for it, then you would use something like the IPython kernel to forward and receive the messages. But there are other languages like Haskell, Julia, mathematic research languages, which have their own internal machinery that can say, hey, no, we can handle this. We can actually handle sending and getting 0MQ and JSON messages to the server, a notebook server, as well as the Qt console and other UIs that's built. So those kind of languages are called, those kind of language kernels are called native kernels. And if you go to the Jupyter site, which the Jupyter is the umbrella project over which IPython has graduated to now. So it seems like now it doesn't make sense to have just Python associated with this functionality. So that's why it went over to now it's called the Jupyter project. But if you look at the Jupyter GitHub repo, you will see that there's lots of languages that are now using the IPython machinery. Yeah, that's all I had about the IPython machinery. Not much of a deep dive, just the fact that you can lay out how the components and all are working together to give us this tool. Any questions on that?
I just curious, is there any in the Jupyter notebook, are there any limitations on what you can do in a Jupyter notebook versus the console?
I wouldn't think so. I would think that
Like
the
you have all the
limitations are
same
more on the console.
debugging. You can do essentially a run-d within a notebook.
Yes, yeah, definitely. Anything that you can type into the console, you can do in in a Jupyter notebook too. Yeah. I'm thinking what other, like you would have autocomplete there, you have syntax highlighting. Yeah, anything that you can type in there, you should have it in the Jupyter notebook. And in fact, the Jupyter notebook also, you can reorder cells and all that. Like you can cut a cell and then you paste it right after the cell, right after the next shell. Sorry, not shell, cell. So it's like it's much more, it's like something you can see at one time, whereas in a console you can't do that while you're
Gotcha.
Yeah. Okay, so there are no questions. So the next thing is, if you have IPython, you can also use it with, say you're working in like a Flask web framework or something like that. So you can use that to, the Flask framework can leverage the IPython program that you have to bring it into its own shell. I don't know how many people have worked with Flask or Django, but you can, when you have a Django installation, you can say Django shell, and then it'll bring up a Python shell, and then within it you can inspect the Django models and all that stuff right within that shell. It's aware of the Django libraries and all that stuff. So if you have autocomplete and wildcard search and all that, when you bring your models up in that shell, I would think it's like very, very useful for that. I don't know if it's let me see if I can code. Okay. So I have a Django installation here which is like the, if you have done the Django tutorial, there's like a bunch of questions, and then you can put up like a poll with questions and choices. It's like a very, very simple app that just demonstrates the Django functionality. So I think you can, yeah, if you say python manage.py.shell, manage.py shell, then if you just have the Python REPL, bring up the Python REPL. But if you have IPython installed, Django detects the IPython installation, and then you can use IPython for your, so like for example, I think I have some. I might need to see some. Django. Oh, there you go. From polls.models, import choice question. Then this is apparently let me see if I can find it. Yeah, so if you see, this is a Django model question, and then choice, where you can apparently, you have a question model, and then which is translates to a question table, and a choice, which is like a one-to-many question to a choice. So if you go to Django shell, choice, you can actually say question objects, no questions. So I make a question here. Oh. Time zone, question, and then, so you can actually introspect a lot of the Django methods from a Django model. So in general, it helps you, do your work much better, I would think. So I don't know how many people are familiar with Django here, but just thought it'd be a pretty trivial example to show as to how IPython helps you here.
Yeah, that's one of the first things I did within Python was Django. That's super cool.
Yeah, definitely. Yeah, we at work we use Flask, but I wish we used Django. Flask is not bad too, I think. I think that's all. Oh, that's weird. That's all I have. Sorry about the short material here.
No need to apologize. That was chock full of really good information.
Oh, cool.
You did fine. I now I got to get busy answering questions and Googling a few thousand answers.
Yeah. So what are some of the things that you find IPython most useful in your general workflow? Like when do you find yourself using IPython, or is it just like when you're doing Python development, you're just using that as your general command prompt?
Yeah, I generally use it. Let's see. I think a lot of it is tied in with IPDB. So when I'm trying to do some troubleshooting or something, I just in a program you can just say. So how you do it is you have a general idea where the program is, where you want to introspect in the program. Let's see. So say, for example, you want to see what happens after this. So I generally go to the program and I say import IPDB, IPDB.setTrace. This is like, I've built it into my editor, which is a Visual Studio Code, where you can like a key command will like, a key map will just like insert this into some place in your program. And then once you do that, you just, run the program and then it'll stop where that import IPDB's line is. And then you can like go and, introspect it. I mean, now it's like, I think a lot of people use PyCharm and all that. So, but to me, I kind of like to separate, like my editor is, I want it to be mostly like very lightweight.
Yeah, I would tend to agree with the doing a lot of things from the command line. I tend to use Git also a lot from the command line, largely for the variation of credential helpers. Sometimes the credential helpers, especially like two-factor authentication,
right.
Primarily with AWS, but two-factor authentication, like to code commit, does not work in anything but the command line.
Mm-hmm.
Yeah.
Well, thank you very much. Does anybody else have any questions, comments, praise?
No, thank you. Thank you for the presentation.
Sure.
Thanks,
sure.
much appreciated.